Well, hello, my good friends. Welcome back. Today's lesson is maybe short on time, but big on content. So, get something to write with and let's begin. So today I'm going to talk about solving quadratic equations by factoring, which means you have to already be a master or perhaps an apprentice of factoring in order to be successful with that. So I've got some other factoring videos. I think there's two or maybe even three on how to factor quadratics, and so go through Marshable math on YouTube. Find those if you can, or watch other ones if you like. There's some other videos online, and I don't make the claim to being the only person that you can learn factoring from. But factoring is one of these things that even when I was in high school in Algebra 2, I had a terrible time doing, mainly because I was taught just how to guess and check. Here, think about all the ways that this thing might go together, and then try every single combination, and then find one that works, maybe. And so I remember one time I tried so many different combinations of something to see if it worked, because it was basically guess and check, that I had erased so much work on my paper. I literally erased a hole in my paper. And I went to class the next day and said, "Mr. Lincoln, man, I can't seem to factor this one." And he said, "Oh, well, you can't. It's prime." Now you tell me. I was so frustrated. But as an adult later on, in fact, I was actually I was teaching algebra, and an older teacher named Mr. Nichols, who was the department chairman, he was observing me one day, and he goes, "Why don't you do it like this?" And I said, "Well, like how, like what?" And he showed me, and I was like, "Oh my gosh, that's so good." So watch the factoring videos. I no longer teach the guess and check method. It's very straightforward. But a lot of students find it frustrating, like I did. And so if you've done factoring before and not been successful at it, have hope. I think there's a better way. Watch my factoring videos. Now I'm going to demonstrate how to do that when I solve these problems every day, because it's solving quadratics by factoring. So I'm going to be factoring. But it's something powerful when you struggle with something and then you're able to overcome it. Oh man, the confidence that you get from that and the satisfaction that you get from that, that's good. All right, so by way of review now, how many different ways can two numbers be multiplied to give a product of 12? Okay, so let's just do a little bit here. Let's see. I'm going to make my pen as thin as I can so I can get in here. I'm going to take two numbers and I'm going to multiply them together and get 12. Okay, how about, well, we'll start at the beginning. How about 1 and 12? Does that work? Yes. How about 2 and 6? Does that work? Yes. How about 3 and 4? Does that work? Yes. And I've gone 1, 2, 3. The next one would be 4, but I've already got it. Does 5 work? Typically, you'd say no. Does 6 work? Well, you'd say, oh, I already got 6 and 2. That's over here. Okay, so I already got that. So 7 work? No. 8 work? 9 work? No. But wait a minute, they do. Well, you could do something like this. I could say maybe like -2 times -6. That would also give me 12. Aha! So negative numbers. I've just found a whole bunch more, right? If I do the negatives of all of these, they would still equal 12. But 5 works. I'm laughing because you're probably very confused. What? What do you multiply by 5 to get 12? Didn't say it had to be an integer. 5 times what is 12? How about 12 fifths? Look at that. Because don't the 5's cancel and just give you 12? Woo! Yeah, how many different ways can you multiply two numbers and get 12? There's an infinite number of ways. Oh man, like let's pick the hardest one. 117 times what is 12? Oh, that's so easy. 12 117ths. Nice, right? I got your brain working already today. That's good. Okay, so if the product is 12, there's like an infinite number of ways. In fact, if the product is anything but a certain other thing, then there's an infinite number of ways. But how many different ways can you multiply two numbers by to get the product of 0? How about, I don't know, we'll do the same thing we did here. 1 times what is equal to 0? 0. How about 2 times something is 0? 0. How about 3 times something? 0. 0. Are you noticing a pattern here? 15 times what is 0? 0. Well, how about this one? How about negative 12 times what is 0? 0. How about a fraction? 5/7 times what is 0? 0. How about 0 times what is 0? Well, you could do 0. That would work. But in fact, you could do any other number in there and it would work. Negative 157. Okay, so 0's got a unique property. If two numbers or more are multiplied and one of them is 0, one of the things multiplied has to be 0. Now that wasn't true for 12. Yes, it was possible that when I multiplied two numbers together and got 12, one of them had to be 12, but that doesn't have to be, right? How about the 2 times 6? Did one of the numbers have to be 12? No. But if I'm going to multiply something and get 0, one of the numbers, or both, have to be 0. Well, we're going to use that. Okay. Now, let's look at an example that we used from the last video. Previous example. Find the zeros. Find the zeros of the function by graphing this. So we graphed this, and then the graph was there, and we said, hey, find the zeros mean the place where the y values are 0. Well, the y values are 0 right there and right there. It's the x-intercepts, right? And so when it says find the zeros, what it means are the x values that make the y 0. What are the x's that makes the y values 0? Well, we said x was equal to negative 2, and then we said x is equal to 3. Okay? Now, follow me on this. I'm going to go backwards. Say, what do you mean? Well, I'm going to take two values and multiply them together. Do you see an x is equal to negative 2 here? Let me move the negative 2 to the other side of the equal sign by addition. So doesn't this become x plus 2 equals 0? Yeah. What about the other one? Don't I move the 3 past the 3 over the equal sign by subtraction? Doesn't this become x minus 3 equals 0? Yeah. Doesn't this number now, whatever it is, doesn't the whole number, x plus 2, aren't I stating that it's equal to 0? Yes. And isn't this whole number, whatever that is, x minus 3, doesn't that equal 0? Yes, it does. Let me multiply them together. X plus 2 times x minus 3 equals 0. Hey, look, I got two numbers, this number times that number, and if one of them is 0, it's 0. And if the other one is 0, it's still 0. But maybe they're both zeros. Let me just multiply them together. What do I get when I multiply them together? Well, you know how to do this. This is polynomial multiplication, right? You're going to FOIL it out. X times x, x squared. X times negative 3, negative 3x. Now I'm done with this x. And then, done with that one. Hang on. Am I doing this right? Yeah. And then I'm going to do this one here. Positive 2. I got so excited I lost track. Positive 2x. And then that's there. And then the positive 2 times negative 3, negative 6 equals 0. And clean it up. Okay. So negative 3x, positive 2x. Oops, not yet. That was an unplanned reveal. X squared minus x minus 6 equals 0. Look, there's an equation where whatever you pick for x would give you 0 then if you substituted it in like that, and if you substitute in x is equal to 2 or x is equal to 3, you get 0. What just happened? What happened? Because that's the same thing. Oh my goodness. I just worked the process backwards. Yeah, these are related to each other. Okay? You may not be totally solid on what happened. Let me walk you through it. Okay? The zero product theorem. The zero product theorem says this. Write it down. When two or more factors are multiplied and the product is 0. I just realized I didn't give you enough room to write. Oh well, such is life. We're gonna roll with it. When that's true, then one, that was not supposed to be a geometry thing. Then one or more of the factors must equal 0. When two or more factors are multiplied and the product is 0, one or more of the factors must be equal to 0. So pause the video and write that full thing down. Okay, back to from unpausing. Let's go back up and talk about this. That was this example right here. When two or more factors are multiplied and the product is 0, one or more of the factors must be 0. Wasn't true of 12. There's not a 12 product theorem. It's not true that when two or more numbers are multiplied and the product is 12, one or more of the numbers have to be 12. Might be, but not have to be. But it is true with 0. When two or more factors, like 3 and 0, are multiplied and the product is 0, one of them, at least, has to be equal to 0. That's the zero product theorem. So how then would you solve quadratics that are equal to 0? What you do is you factor them and then set each factor equal to 0. So let me do example number 1 here. Write a quadratic equation in standard form with -1/3 and 6 as its roots. Roots? What are those? Standard form. Do you remember what that is? Quadratic equation. Okay, quadratic equation. ax squared plus bx plus c equals 0. A function is just equals f of x. Okay, that's a quadratic equation in standard form. With -1/3 and 6 as its roots. What are roots? Those are x values that give you y equals 0. That's what I did right here. Look, I took x values that made the y value 0, and I made factors out of them and multiplied them, and that gave me the product of 0, and there's my answer. So we do the same thing down here. So if x is equal to -1/3 and x is equal to 6, let me set the right hand side of both of those equal to 0. So on the left hand side it would be x plus 1/3 is equal to 0, and this would be x minus 6 is equal to 0. Are you cool with that? Okay, so now I've got two numbers, this one and this one, that I'm saying are both equal to 0. Let me multiply them together. But before I do, the fraction over there on the left-hand one is going to be a bit of a pain in the pitucci. Whatever a pitucci is. Can I eliminate that fraction before I actually do the multiplication of these two numbers? Yes. What number can I multiply the left-hand side by that would cancel with the 3 in the denominator? Well, a 3 in the numerator. So multiply the numerator here by 3 and multiply the right-hand side over here by 3. If I distribute this 3 and it becomes 3x plus 1 is equal to, what's 0 times 3? 0. See, that side didn't change. It's like it's great. It's like what? Yeah, it's the same thing. Okay. If I were to then somehow like take this and solve it for x, wouldn't I subtract 1 divided by 3 and that would give me negative 1/3? Yeah, so it's equivalent, okay? So now this is the thing that I want. Take this package, that package, and now multiply them together. So I'm going to then come over here and I'm going to say 3x plus 1 times x minus 6 is equal to 0. Okay, here's my 3x plus 1, here's my x minus 6. Okay, multiply those. So FOIL it on out if you like. I really don't like that phrase because it's not always true for multiplying polynomials, but it works for now. 3x times x, 3x squared. 3x times negative 6, negative 18x. 1 times x plus x, 1 times negative 6. Negative 6 is equal to 0. Clean up the middle. 3x squared, a negative 18 plus x would be a negative 17x minus 6 is equal to 0. There we go. Okay, have we answered the question? Write a quadratic equation in standard form with negative 1/3 and 6 as its roots. Yes. All right, so let me write it down here in the blank. 3x squared minus 17x minus 6 equals 0. It's an equation. It's got to be equal to something. Now, what's going on? Well, if I were to graph it, I'm just going to do a quick little sketch here. Sketch is not part of the answer. I'm just doing it to demonstrate for you. It's a parabola that's going to open up. How do you know that? Because the leading coefficient, the a term, is positive. Okay? And it's going to have roots, the x values that make the y value 0 at negative 1/3 and 6, which means somewhere way over here at negative 1/3, which is maybe like right there, and then someplace way over here at 6, it's going to cross the x-axis, and so it's a parabola that's going to look like that somehow. Negative 1/3 is where it crosses there, and positive 6 is where it crosses right there. This equation will look like that when you graph it. Nifty, eh? Okay, so how would you do that? You would do it like this. You would do x minus the first root times x minus the second root equals 0. And notice over here, if I did a negative 1/3, where is it? It was negative 1/3. If I do minus a negative, it winds up being a positive. Okay, so that's the analytic way to do it if you want to kind of like have a pattern to do. But if you're comfortable with just kind of setting each thing equal to 0, like I did right here, and then multiplying these two things together, you'll get it. Okay, good. Now, on to the big stuff. Solve by factoring. Well, what I have to do is this. I have to get an x minus a root 1 times an x minus a root 2 equal to 0. And then I can say x minus root 1 equals 0. And I can say also x minus root 2 equals 0. So I'm going to factor it. Factor the whole thing. Now, the thing that you should look for when you factor is the greatest common factor first. Always look for the greatest common factor. So in here between 16x squared and 8x, because it's already equal to 0, if it wasn't equal to 0 first, I'd have to make the right-hand side equal to 0. What's the greatest common factor between 16x squared and 8x? I think I can factor out an 8x, which leaves me remaining 2x plus, don't tell me 0, plus 1. Because if I were to multiply it back out, right, is 8x times 2x 16x squared? Yes. But 8x times 1 is also 8x. You have to put the 1 there as a placeholder for that. You can't leave it blank. Okay. Now, keep going. Don't drop your structure. Equal 0. Now, have I got two things that when I multiply them equal 0? Yes. Stop. New equations. That means 8x must equal to 0 and 2x plus 1 has to equal 0. Notice my squiggly line there? That's me stopping the first process and starting a second process. Okay, this is now that I've just shown for you, this step right here, this is the zero product theorem, this step right here. A lot of students want to skip this step, and I don't give full credit if you do, because then you're skipping the mathematics. Why are you allowed to do two separate things set equal to 0? Because I have two or more things that are multiplied, right? Isn't that multiply there in the middle? And the product is 0. That's why I'm justified in doing that. I take the factors and I set each factor equal to 0, and then I keep going. So keeping going now on the left, how do you do 8x is equal to 0? Well, I divide by 8, divide by 8. But you know that x is equal to 0. There's one of my answers. Okay. Now to solve this one, let's pass the 1 over to the other side and then divide by 2, divide by 2. X is equal to 1/2. There's my two answers. Let's check them just to be sure. We got time. Let's check them. I'm gonna come over here. Let me just erase this. You don't need that. I'm gonna go sideways here, and I'm gonna plug in 0. Is 16 times 0 squared plus 8 times 0, is that equal to 0? Hopefully you can see, yeah, it is. That both of those terms are 0. But what about a half? 16 times 1/2 quantity squared plus 8 times 1/2. Oh, look at that. I bumped myself. You probably saw this several minutes ago. I forgot the negative right there. And now that I'm doing the check, I'm realizing it. And maybe it's good to check your answers. I've said it before, I'll say it again. If I make a mistake, when I make a mistake, the majority of the time it's in mismanaging a sign. I get going too fast and I forget to take care of the sign. So 16 times, let me fill this in, negative 1/2. Go back to blue. All right, so now plus 8 times negative 1/2. Is that equal to 0? Okay, what is 16, or what is negative 1/2 squared? It's 16 times 1/4, positive 1/4, right? Because this time the negative is in the parentheses, so it's squared. And then minus 4. Is that equal to 0? Well, 16 times 1/4 is 4. Is 4 minus 4 equal to 0? Yeah, they both work. Okay? Good. Now, that's crucial. So my answer then is going to be x is equal to 0, and x is also equal to negative 1/2. Good. Hey, how many solutions do you have on this question? 2, right? One here and one there. I don't know why you would think that you would have 2. Like, how would you expect to have 2? Like, I don't know. Example number 3, solve by factoring. All right, so let's get it down here. All right, so the first step is to make the right-hand side equal to 0. Did I do that? Yes. It's already done for me there. Now the next thing, do I have a greatest common factor? No, I don't. Okay. Now, I've got a trinomial. I'm going to do, if you follow the factoring videos, if you know how to factor, what I'm going to do is I'm going to take the c term. What do you mean the c term? This is ax squared plus bx plus c equals 0. And my a in this case is 1. So my a is 1. So I'm going to take the c term, which is 64, and I'm going to break it into factors. What are my factors of 64? And I'm going to be systematic. 1 times 64, does 2 work? Yeah, that would be 32. Does 3 work? I don't know, I gotta reach for my calculator. I think 3 works, but maybe I'm wrong. No, I don't think 3 does work. Let me try. So 64, make a complete list, divided by 3. Is that an integer? No, I didn't think it was. So that's out. So 4, does 4 work? 64 divided by 4, I'm sure that works. That's 16, yeah. 64 times 5, 5 doesn't work. Does 6 work? 64 divided by 6 equals, no. Well, if 3 doesn't work, but 2 does, 6 won't though, because it's got to be divisible. 6 is divisible by both 2 and 3. Remember those divisibility rules that you learned maybe in 5th and 6th grade or something like that? I don't remember much either, but I do remember learning them. It's different if you forget what you've learned compared to forgetting that you ever learned it. Those are not the same thing. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8. Obviously 8 times 8. I think that's it. Okay. So there's my complete list. Now, here's the key thing. I need to find a pair of these factors that when I add them, because that sign is plus, when I add them, I get that number. Do 1 and 64 add together to give you 16? No, they add together to give you 65. Does 2 and 32 add together to give you 16? No, that's 34. Do 4 and 16 add together to give you 16? No, that's 20. Do 8 and 8 add together to give you 16? Yes, they do. So this is the pair now that I want. And so because my coefficient is 1, I can say x and an 8, and then an x, and then another 8 equals 0. Now, how do I get a positive 16 now from an 8 and an 8? Notice I didn't put the sign in there. I didn't put a plus or a minus in there. How do I get a positive 16? By adding together an 8 and an 8. They both have to be positive. Okay? Because if you multiply them out, the first term here is going to be x squared. The last term is positive 64. We've already done that. But the middle term is going to be a plus 8x and then another plus 8x. You get the middle term. You get this by adding together these two things, 8 and 8. And you get that by multiplying them together. Yeah. But wait a minute. These are actually the same thing. So, I mean, technically I could say it's going to be x plus 8 quantity squared is equal to 0. And you should know that by now, really. Because what we just did, this is going to be a, you remember this factor pattern? You should remember that, oh, how did it go? It's going to be a plus b quantity squared. That gives you a squared plus 2ab plus b squared. Remember those patterns? You should know those patterns. Anyway, that's what we got going on here. But we're solving it simply by factoring. So actually, I don't really need this. Okay. Now, do I have 2 or more factors that when I multiply them together, they equal 0? Yes. Stop. New equation. X plus 8 equals 0 and x plus 8 equals 0. Solve both of those. X is equal to negative 8 over there and x is equal to negative 8 over there. And so actually we've got one answer. X is equal to negative 8. Actually we've got one unique answer. Okay? They're the same thing. But I did get 2 of them, right? You saw that I got 2 of them because I had 2 factors. That would be like a graph, like we talked about previously. That would be like a graph that just maybe, let's see, it opens up. Yeah, it opens up. It comes down and it just touches at x is equal to negative 8. Doesn't cross, touches it and turns around and goes back up. Okay, that's one unique real solution, but 2 actual ones. So like, I'm sure it's a big secret, but like, I don't know why you would ever think that this equation would have 2 solutions. Solve this one by factoring. Okay, the first thing we have to do is set the right-hand side equal to 0. So that's going to be x squared minus 64 equals 0. Now, you can solve it by doing the long process. Factors of c that when you subtract them give you 0. But you actually should recognize this. Remember this factor pattern? If I had a plus b multiplied by a minus b, that middle term would drop out and I would get a squared minus b squared, right? Remember difference of squares? You should. Watch the factor video. This is going to be something squared minus something else squared is equal to 0. What's the root of these things? In blue, it would be an x there. And what's the square root of 64? 8. Okay? So now this factors into conjugates. Hopefully you know that word. Conjugates. Conjugates are binomials that are the same, x and 8 and x and 8, except for the sign. One's positive, one's negative. Okay, there we go. X plus 8 times x minus 8. When you multiply those together, the middle terms cancel each other out because one of it is plus 8x, the other one's minus 8x, and they cancel. That's why there's no b term on this one. This was, if this is ax squared plus bx plus c equals 0, at this point right here, a is equal to 1, b is equal to 0, and c is equal to negative 64. Okay, but now, do I have two factors whose product is equal to 0? Yes. Stop. Hammer time. New equation, x plus 8 equals 0. So x is equal to negative 8, and x minus 8 equals 0. So when I move 8 to the right side, x equals 8. Positive and negative. How many answers did we get? 2. Gee, I wonder why. We're not going to talk about that. So x is equal to negative 8, and x is equal to positive 8. There we go. Okay. Now here's a new one. Those first ones were easy. This one's a little more challenging. Solve by factoring. Okay, so is the right-hand side equal to 0? Yes. Is there a greatest common factor? No. Now I need to find factors of c because my coefficient is 1. If it's not 1, we have to do something different. We'll do that next. But for this one, it's 1. So c is equal to 20. List all the factors of 20. Start at the beginning. 1 times 20, 2 times 10, 3 doesn't work, 4 times 5 works, 5 is next, but I've already got it, so I'm finished. Which ones of these factors, when I do this to them, I have to add them? Which ones, when I add them, give me 9, 4, and 5? Okay, so this factors into an x and a 4, and then an x and a 5 equals 0. Don't drop the equals 0. Always include that along. It's an equation. Keep it going. Now, what are the signs? S-I-G-N. How do I get a positive 9 out of a 4 and a 5? They both have to be positive. Now, if for some reason the middle term was, say, like positive 1x, you would have to be subtracting, right? Something like that. Or if it was, let's say it wasn't a positive there, let's say it was a negative 9. How would I get a negative 9 from a 4 and a 5 when I add them? You would have to do a negative and a negative, right? And if you can do that, fine. If not, please go back and watch the factor videos because I can't get into it right now. I expect you guys to be able to do that. But it wasn't a negative 9, it was a positive 9, so back we go again, okay? Now, do I have two factors that when I multiply the product is 0? Yes. Stop. Hammer time with a new equation. X plus 4 is equal to 0, so x is equal to negative 4. And x plus 5 is equal to 0, so x is equal to negative 5. Again, how many solutions did I get? 2. Why would you know that? That's for me to know and you to find out. One of these days we'll talk about the fundamental things of algebra. All right, solve this one by factoring. All right, so now here we go. Okay, this one's now complicated. So, again, let's see here. This is ax squared plus bx plus c equals 0. Yes, I do realize that now we have y as a variable. You may ask, why is that? Because you need to be able to do them with other variables other than x. X is just a kind of like a generic thing. It just fills a spot. So why ask why? But let's see here. Right-hand side equals 0. Yes. Greatest common factor. I don't know. I could maybe factor a 6 out. Does 6 come out of 23? No. Doesn't come out of 20 either. The other factors of 6 are a 2 or a 3. Do either one of those, are those factors of 23 or 20? Well, it's got to be everything, and 23 is the problem number there, so that doesn't work. So no, there's no greatest common factor. Okay. Now, a is not equal to 1, and so we need to use factor by grouping. Factor by grouping means the AC method. So I'm going to take the A value, the A, times the C. In this case, it's going to be 6 times 20. What's 6 times 20? Is that 120? Let's do a little work here. I need to make a list of all my factors of 120. Well, obviously 1 times 120. 2 times, what would that be? I'm embarrassed, but My brain's getting tired. Oh, 60, of course, yeah. 3, 120 divided by 3, 40. 4, I bet 30. 5, 120 divided by 5. That works. 5 and 24. 120 divided by 6. Didn't we already say that that was 6 and 20? Okay, 120 divided by 7. Not an integer, so it doesn't work. 120 divided by 8. 15. 120 divided by 9 doesn't work. 120 divided by 10, 12. 120 divided by 11 probably doesn't work. Nope, not an integer. 120 divided by 12. Oh, I already have 12, so I'm finished. Wow, okay, lots of work. That's the method, show the method. Now, what am I looking for here? Let me get rid of that line here. I am looking for factors, factor pairs, a pair here or a pair. Which ones of these factor pairs, when you do that sign on them, that's a plus. Which ones of these, when you add them, give you that number? Ignore that sign, just think about that number. When you add 1 and 120, does it give you 23? No. 2 and 60? No, that gives you 62. 3 and 40? No, that gives you 43. Jump down to this one. Ooh, 8 and 15. Is 8 plus 15 23? I think so. So here's what I do. This is a little more complicated. I take this middle term and I break it into two parts. I break it into an 8y and a 15y. I split it into two pieces. Now, how do I get a negative 23? Don't both of these have to be negative? A negative 8 and a negative 15? Because if I were to add those together, wouldn't it be negative 23? Okay, this is splitting the middle term. And now I'm going to copy down 6y squared. And I'm going to copy down the plus 20 equals 0. And now I have 4 terms, and that's how you would factor by grouping. Okay, keep going. Now what I'm going to do is I'm going to imagine the middle, the group cut in two little pieces. I've got a piece on the left of that green dashed line. I got a piece on the right. Don't put parentheses around these. That changes it to a multiplication problem. I'm just going to look at the middle two, or the first two as a group. What's the greatest common factor there? That's got a greatest common factor. A 2y. And then what do I have remaining after I factor out a 2y? That would be a 3y minus 4. Correct? Okay. Now, if it's going to work, you have to be able to do the same thing on the right-hand side and get the same 3y minus 4. So I'm going to tell you, go ahead and write it in hope, in faith that it's going to work itself out. Now, what do I factor out of a negative 15y to give myself a negative or a positive 3y? Or in other words, what do I multiply 3y by to get a negative 15y? Do you see that that would have to be a negative 5? And just to double check, if I take negative 5 times negative 4, does that give me negative 20? There it is. So I've got it almost factored by grouping. Do you see that now I have a common factor of 3y minus 4 in both of these pieces? Factor that out. Factor out a 3y minus 4 out of that group. If I cancel that and I cancel that out of there, what do I have remaining in green? I have a 2y minus 5. Oh my goodness, this is so complicated. But we're getting through it. Equals 0. Finally! I've got two factors that are multiplied together and the product is 0. What does that mean? Stop. Hammer time with new equations. Set each factor equal to 0. 3y minus 4 equals 0. So add 4. 3y is equal to 4. Divide by 3. Y is equal to 4 thirds. Finally. And then set this one equal to 0. 2y minus 5 is equal to 0. So 2y is equal to positive 5. Divide by 2. Divide by 2. Y is equal to 5 halves. There you go. Did I get my 2 solutions? Yes, Mr. Marsh, but how did you know that you were going to get 2 solutions? I don't know. Oh. There's my answers. And I think the exercises are next. Is that the last one? Yeah, there we go. There we go. Whew. Okay. All right. So now, back to me. When 2 or more factors are multiplied and the product is 0, 1 or more of the factors must be equal to 0. Your job is to solve by factoring. Set the right-hand side equal to 0, and then set each individual factor, equal to 0. Well, it's a long lesson. Good luck with the exercises, and I'll talk to you next time. Bye-bye.